So today we're going to talk about the formation of an acetal from a ketone and alcohol. So in this case we'll talk about acetone and two equivalents of methanol coming together to form dimethyl acetal. And so we can stir acetone and methanol together and it won't form the acetal. But if we add some catalytic acid, in this case tosylic acid or our HOTS reagent, we will form the acetal, and in the process we give off a molecule of water. And this reaction is reversible, and so we can favor the equilibrium towards the acetal or the ketone by simply changing the amount of water in solution using Le Chatelier's principle. And so the first step of acetal formation is protonation of the ketone. The electrons of the oxygen pick up the proton and kick out the tosylate anion. And so we've made a positively charged oxygen, and the counter ion is the tosylate anion. This protonated carbonyl structure we know is resonance stabilized. And the electrons from the carbon-oxygen double bond can be pulled up to the oxygen to leave behind a carbocation. And so the protonation step is reversible. The next step of the mechanism involves addition of methanol to the protonated carbonyl. So the electrons of methanol can attack the carbon atom. We can use either resonance structure to do this with. So we then have the oxygen that came from the methanol, positively charged, and we have an OH also attached to the carbon. We can then do the proton shuffle, so switching the transferring the proton from one oxygen to the other. And in doing so, we make water, which is a good leaving group. And then we have our neutral oxygen from the methoxy group. We can then use the electrons of the methoxy group to kick down and kick out the water molecule. So this is the stage in the mechanism where we lose water. And we have, again, a positively charged oxygen atom that has one bond to carbon and two bonds to the other carbon. And this compound is resonance stabilized, in which we have a carbocation, carbon-centered cation. So we can then take our structure and have the second equivalent of methanol add to the carbon. So we have a structure that looks very similar to the products that we want. However, we have an extra proton on one of the oxygen. So our tosylate anion that's been floating around in solution can then come back and remove the proton to remake tosylic acid, that's why it's a catalyst, and to give us our acetal. And that's how you make an acetal from a ketone and two equivalents of alcohol under acid catalysis.